Hello. Good morning, good afternoon, everyone. Welcome aboard. Good afternoon. Guys, can you hear me? Can you see me loud and clear? Do let me know. Hi, Anjali. Hi, Sashti. Focus, user, Abdul. Hello, Pragya. Hello, everyone. Can you guys see me? Can you guys hear me? Do let me know in the chat box. And I hope I'm loud and clear. So, how was it? Was it easy peasy lemon squeezy? How many of you said it was easy peasy lemon squeezy? Welcome aboard. This is Shreyas here, your physics master teacher, going live on your favorite Vedantu Enthuse and V Biotonic, and we are going to discuss the entire paper just for you. And it's time to now relax, cheer up, because I'm pretty sure you all did well. Easy peasy. Did you see many questions coming up from the sessions directly or indirectly in the past 4 days, whatever we did? Did you see so many things just came directly? And I'm pretty sure those of you who were not at all confident 4 days back and you got so much of confidence in the past few days are now like, sir, yes, we nailed it. We nailed it. Roman already agrees, Sakshi agrees, Sanjana agrees, Shivani also agrees. Perfecto. So guys, this is what it is all about. Stay with me. Just listen to me. Follow whatever I'm telling you. It's not just about boards. I will make sure you even crack BitSat, you even crack J, and you will get the best college next year. You will be partying. You will be enjoying in the hostel. You will be probably celebrating. You will be having freshers. You will be, I don't know, in some club. How many of you are going to rock it next year? Please let me know in the chat box by putting up a yo symbol. Yes, there were some tricky questions too. Don't worry, we are going to do that as well. We are going to do that. Yes, for JEE, for NEET, everything. Don't worry, bacha log. Let's begin the session. And this is Shreyas here, your physics master teacher. And you have anything to ask, you know where to go. Go to Instagram. That's my Instagram handle. You can definitely get in touch with me. Very good. Let's get going. Now I have two sets. So I think the set number 2 is still getting typed or whatever, it's still getting aligned. So meanwhile, I hope you have already smashed the subscribe button and I hope you have already smashed the like button. A big thanks to all of you. So let's get going. If you have forgotten to do so, do that right now. Yes, let's get going. Yep, set 4. So these were the questions that we have gathered from our students. These are the photos out here. Just 1 second, guys. Just 1 second. All right, cool. So there is a negatively charged object X which is repelled by another object Y, and there is another object Z out there, and the question says that if it is attracted to Y, which of the following is the most probability of object Z? Yeah, if X is negatively charged and it is repelled by another object Y, and that is, if it is repelled, then obviously this Y must be also negatively charged. And if there is attraction between Y and Z, then Z can be either positive or even neutral. Why can it be neutral? I have discussed this in my NCERT. Okay, don't worry, Arunima and others, we are going to discuss both the sets. Yep, we are going to discuss both the sets. Hold on. Let me get done with this set. Immediately I'll come with the next set. Okay, I will do. This is SSJ 2, SSJ 1 will also come, the set 4. Yep, this will also come. Okay, don't worry, we are going to come. Okay, so answer C, neutral or both, positively charged. Both answers will be correct. Be careful about it. Okay, all right. So those of you joining in a little bit late, let me tell you, I'm discussing SSJ 2 set 4. After this, we'll do SSJ 1 set 4. We are going to do both of that. Hold on for some time. In an experiment, 3 microscopic latex spheres are sprayed in the chamber. They become charged by 3, 5, minus 3. Now, if they come in contact for some time, which of the following are the possible values? I gave it to you in NCERT underline here. In my NCERT underline session, I told this to you. This is all about charge conservation. This is all about charge conservation. What is the total charge? Come on. Even if it is not your set, let's see if we can solve this. Guys, if it is not your set, still you should be able to do this. Come on, what is the total charge? 3 plus minus 3 is 0, 5. So total charge is 5. So which of these following gives you a total charge of 5? Do you see that? 6. 6, 12, 12 minus 7 is nothing but 5 again. Yep, it is option B, correcto. So just you had to add all the charges out there and you will get the answer. Bharat, oh my God, you don't have to spend 40 rupees for that. Thank you so much for the super chat. Yes, Bharat, we are going to come to the different set also. Just for now, hold on to this because there are other students who had this set. We are going to come to all the sets. All the sets will be discussed, okay? All the sets will be discussed. Don't worry about it. I'm going to come to that. There is an object which has a charge of 1 coulomb which gains these many electrons. The net charge on the object becomes how much? Now, understand over here the concept is already there is a charge of plus 1 coulomb. When you add these electrons, the electrons have negative charge. So, you have to add these many electrons charge, which is 5 into 10 to the power 18 into, what is the charge of each electron? Minus 1.6 into 10 to the power minus 19. Just do the math. Come on, do the math. 16 5s are 80, so it will become 0.8. So 1 minus 0.8, that will be how much? 0.2. 0.2 should be the answer. Got it? Very good, very good. Let's get moving to the next question. Okay, so I'm guessing there were yes, so I'm guessing there were 2 sets, I guess, even though the sets were 4, but I think 2 of them were same. Okay, we are going to see all the sets. Don't worry, Sandeep. Okay, Kirchhoff's rule says net current is 0, and the second rule says, we discussed this, net current into resistance is the total EMF across that loop. Where the symbols have the usual meanings, then what is it based on? We all know this is the Kirchhoff's current law. This is your junction law. And what is junction law based on? The junction law is based on the conservation of charge. What comes in should go out. And conservation of energy decides this, because when you go across the loop, the net voltage difference is 0. So this is your Kirchhoff's voltage law based on conservation of energy. Yep, correcto. So hence answer D is correcto. Very good. All right, Subramanyam. Yes, yes. So what will happen is our content team will just put all the questions on each slide so that you know it's all there for you. Number 2, there are teachers working behind the scenes who are going to post the answers out here so that you know you get to know the answers for each and every question. Don't worry about it. Moving ahead, electric power consumed by this bulb, which is of 100 watts at 220 volts. Then what happens when it is at 110 volts? Which formula will you use? I did this question yesterday only. Power is a voltage square by R. See, what will happen is that when you change the voltage, then the power will also change. So you can see that when you shift it from 220 volts to 110 volts, you have made the voltage half. You have made the voltage half. So V square will become 1 by 4 times. Resistance will remain the same. So basically what will happen to the power? The power will become 4 times less. 4 times less. Hence it will become 25 watts. Makes sense, my warriors? Is that all clear? Easy peasy, lemon squeezy. P is equal to V square bar. Voltage becomes half. V square becomes 1/4 times. That's it. Perfecto. Yes, this is the board exam paper. Guys, it's very easy. It's looking very easy peasy lemon squeezy in front of the questions that we solved. And most of you are worried, sir, paper will be tough. But it is actually looking very easy, at least till now. Which of the following has negative temperature coefficient? This also I told you. Alpha. Remember my NCERT underline series? I told you over there. Alpha can be positive, it can be negative, and I told you that it is true for semiconductor. You will learn this in term 2, but I mentioned this very clearly in my session. So if you have attended this, you already know the answer is option C. Perfecto. The answer is semiconductor. Metals have positive, even alloys have positive, okay, but semiconductor has negative. So when you increase the temperature, the resistance decreases. Guys, this question reminds me of yesterday when we are doing sure shot high weightage questions, and then somebody asked, sir, please do a question on Biot-Savart's law. How many of you remember I did the same problem and I made you understand the directions? How many of you remember I drew this yesterday? Only difference was the currents were not going up, the currents were going like this. Yesterday only I did this. Glad to know that, Muhammad Alaz. All right. Okay, don't worry, Sarmesh. We are going to come to the next set also. We just did it. We just did this. So basically, it's the same thing out here. So when you see the current is going up, use your right hand rule. Use your right hand rule. You will see because of this current, the magnetic field is coming this side and it is going inside like this. So that's how it looks. Just because of this current and because of the current which is in the horizontal direction. Again, curl your fingers, it comes towards you, and it goes inside like this. So it has to come vertically up, that means towards you. So that's region 2. That's region 2. Both the dots are coming towards you, isn't it? Yep. This looks easy. Let's get moving to the next question. There are two parallel conductors carrying current of 4 amperes and 10 amperes and are placed 2.5 centimeters apart in vacuum. Okay, what is the force per unit length? Which formula are you going to use? The formula that you are going to use is mu naught I1 I2 length divided by 2 pi r. Wasn't this the formula, guys? That's it. So everything you know mu naught's value is 4 pi into 10 to the power minus 7. Currents are 4 amperes and 10 amperes, and the force acting per unit length is asked. So shift that length below over here, so it will become divided by length. So that's it. You will get the answer. And the distance is also given as 2.5 centimeters. I hope this is clear. Understood? Very good. Siddharth saying already he has scored full marks. Perfect. Looks like you guys are doing very well. If an ammeter is to be used in place of a voltmeter, then we must connect with ammeter. If an ammeter is to be used in place of a voltmeter, then we must connect with the ammeter. What do you do for an ammeter? I told you this. What do you do? I gave you the reference of Amma. So current comes, there is Amma waiting with a slipper. Amma is waiting with a slipper. If Amma is waiting with a slipper, what will you do? You will go from a separate direction. You will bypass Amma. You will go from the side door. You need a shunt resistance. And that shunt resistance, what is it? It is very low resistance. Do you remember this? I mentioned this about Amma, correct? So hence, you have to go via shunt, low resistance in parallel, guys. Very good. Yes, Simple Girl already remembers it. Okay, so I'm just going to go back and refresh this just in case some of the new slides have been added. Okay, moving ahead to the next question. The magnetic field at the center of a current carrying circular loop of certain radius is this much. The magnetic field at a point on the axis at some distance from the center is this much. What is the ratio? Guys, this also formula revision session 2 days back. I gave you this. When you are at the center, the formula for field B1 will be mu naught I by 2r. But when you are on the axis at a distance r, then the formula, okay, at an axis at a distance of r from the center of the loop will be mu naught I r square divided by 2 r square plus r square raised to 3 by 2. Just do the math and you will get the answer. Is it coming out to be 2 root 2? Very good, Shubham. You scored 32. Very good. Dhanush, 33 is good. Pacha, 33 is good. Don't be sad. Be happy with what you're getting. You just lost 2 marks. It's fine. Term 2 mein you will get full marks. Stay with me. At least you got 33. Be happy. Don't worry. Don't cry so much. Okay? Chalo. Moving ahead to the next one. The self-inductance of a solenoid is of having 600 turns is this much millihenry. The self-inductance of a coil having 500 turns with the same length, same radius and same medium. I gave you this formula in my formula revision class. In my formula class, I gave it to you. Formula session. So I mentioned about this that the inductance is nothing but mu naught pi r square and then you have n square into the length. This n is nothing but number of turns per unit length. Okay, so that's what this is. So basically what has happened, the 600 turns has turned into 500 turns. So that's all you need to do. Inductance 1 upon inductance 2 is number of turns 1 upon number of turns 2 whole square. You already know L1, you know N1, you know N2, only thing L2 you don't know. That's it. Yes. Okay, very good. Just one, don't worry. We are going to come to the other set as well. We are going to come to that as well. Perfect. So I think the answer comes out to be 85 millihenry. Very good, DM kids. YT already posted it out. And okay, maths was difficult. Yes, physics was easy. Looks like it, at least from here. Guys, this question I did it yesterday in my sure shot series. This was a question from sure shot. Values are different, that's all. The RMS current is given and the question is what is the value of current after this much time. So current in general will be I naught sine omega t. What is I naught? RMS is 15. So I naught will be 15 root 2 because this, remember, is the RMS value. So the peak is always RMS into root 2. So this is peak value. Sine omega is 2 pi f. What is f? 50. Time is 1 by 600. So 0 0 goes, 2 5s are 10. So pi by 6. So pi by 6 sine is half. So 15 root 2 by 2, which is 15 by root 2. That should be the answer, which is option A. Correct. Very good. That's the answer. Yep. Understood? So question number 11. Yeah, question number 11 may just use this. L1 by L2 is N1 by N2 whole square. Reason is inductance is proportional to turns square. Remember the formula. Now you know everything. L1 you know, L1 you know, N1 you know, N2 also you know. Only thing you do not know is L2. Just do the math. Now you will be able to do, bacha. Garima Yadav, I hope this is clear. Okay. Moving to the next one. Okay, great. So in a circuit, no, 90 is not coming. It is going to be 85. 75, my bad. 75. It should be 75. Just check this out. Moving ahead to the next one. Okay, this is SSJ2 set 4. Okay, this is SSJ2 set 4 questions. After this, we will be going to SSJ1. Okay, so all the sets will be covered. So be it set 4, 3, 2, 1. So if you are having this code over here, this is what we are discussing now. After this, we'll be doing set 4, 3, 2, 1, everything. After this, that's what we are going to do. All right, cool. Chalo, let's get moving. The circuit phase difference, alternating current, source voltage is pi by 2 between the current and the voltage. Which of the following cannot be the element of the circuit? Come on guys, this is very interesting. Only C. See, only C, yes, possible. Because voltage and current, I have already told you, if current is like this, voltage is here. Only L, yes, voltage is here, current is like this. L or C, yes, you can have voltage either up or down and current will be here, correct. When you have L and R, then it becomes a problem. The voltage will be here and the current will be here because voltage across inductor will be on the upside and voltage across resistor will be on the horizontal side. The resultant will be here and this angle will not be 90, it will be an acute angle. So hence option C is correct. Perfect. Moving to the next one. Hi Abhay, welcome aboard. Yes Anjali, we are coming to SSJ1 also. The electric potential V at any point is given by this. X is in meters, V is in volts. The field at any point is, yeah, I did this question in sure shot. How many of you remember this? Voltage is given, so dV by dx is nothing but derivative of basically 3x square, which is nothing but 6x. So electric field is minus dV by dx. So it is nothing but minus 6x. X value is 1. So if you put x is equal to 1, you are going to get it as 6 along negative x axis. Do you remember guys, direct questions from my sessions? Direct questions from my sessions have come. I mean, it would be really bad if you have not attended my sessions and you know, now you are realizing that so many questions came or you did not pay attention to it seriously. You will feel very bad about it. So many questions, at least, yeah, I can see 5-6 questions out of 14 questions now. Next one, which of the diagrams correctly represent the field between the two plates if neutral conductor is placed between them? Okay, if a neutral conductor, see this is the neutral conductor over here. Now the key word is conductor. So for a conductor, we all know that the electric field is directly perpendicular. Electric field is directly perpendicular to the conducting surface. So you can see over here field between two charged plates. Yes, so over here it is perpendicular. Here there is no field. How can there be no field over here? How can there be no field over here? This doesn't make sense. Here, how can the field lines be parallel? I mean, they should always be perpendicular. Okay, they should curve, they should bend. So they are not even bending. Okay, there is no bend over here. So out. And over here, why are the field lines, originating from here? Some of them should terminate and some of them should originate. This doesn't make sense because some of the field lines over here should also come over here, right? Where are those field lines? Those field lines are not there. So A is also wrong. D is the correct answer. You can see all the properties are being met. Also remember, it's a neutral conductor. That means net charge is 0. That means some field line should originate, some field line should terminate. Here all of them are originating. Here some are originating, some are terminating. Hence D option is correct. Moving to the next one coming up on your screen. Very good, very good. Yes, I'm going to do SSJ1. So those of you are joining in late, right now this is SSJ2, SSJ1. All sets will be done after this, just immediately after this, okay? Variable capacitor is connected to a battery. Capacitance is changed from 2 to X microfarad. The decrease in the energy of the capacitor is this much. What is the value of X? Okay, so guys, that's a variable battery. The capacitance changes. So which formula are you going to use? Basically half C V square. Initial energy, this is final energy. So this is initial capacitance, this is final capacitance. So the decrease in the energy. So basically delta U will be half delta C into V square. Do you know delta U? Do you know delta U? Yes, you know delta U, 2 into 10 to the power minus 2. Do you know voltage? Yes, you also know the voltage. What do you need to know? Delta C. So that's the only thing which you can find out from here directly. Yep, I hope this is clear. Very easy, right? Very easy. So guys, if you have missed any of the previous part, even in a live class, you can go behind. Just tune in behind. Just scroll. Just slide that pointer behind. You can go back to the previous questions answers. Moving to the next one. Potential difference of 200 is maintained across conductor of resistance 100. The number of electrons passing through it in 1 second. Yeah, come on, this is easy. Voltage is known, resistance is known. So from this you will get current. Current is V by R, correct? Now after that, the number of electrons. So I is nothing but charge by time. So charge will be nothing but number of electrons into electron charge divided by time. That's it. So this is equal to V by R. So what and all you know? Voltage, resistance, time, electron charge. Only thing you do not know is number of electrons. Yep. Is that clear? Shall we go ahead? I hope you are understanding. We're just doing the concepts. Rest all calculations you can do it. I want to discuss just the answer key because I know you want to start preparing for chemistry after this. All right. So let's quickly move ahead. Impedance of LCR, guys, this was direct. D, R square plus XL minus XC whole square. This was direct. Okay. Chalo, this was a direct question. You should know this was R and this is XL minus XC and this is Z. So I had told you about Pythagoras over here. This was also done in my formula session. Done. Moving ahead to the next one. There is a voltage, AC, current, also AC flowing through it. What is the average power? Clearly it is very obvious. D option is given. See this. This is the phase difference. Phase difference is 0. Phase difference is 90. So cos phi is 0. So power is also 0. This is your power factor. Okay, this is your power factor. Some of you said power factor was deleted, but in spite of that, I discussed it in the class. So it has come over here. So power factor is 0. Perfecto. Okay, let's get going to the next one. Current carrying wire kept in a uniform field will experience maximum force when? Current carrying wire will experience maximum force when? Force is nothing but which formula? ILB sine theta. So if F is maximum, theta should be 90. So hence it should be perpendicular. Perfecto, perpendicular. Excelente. Moving ahead. Okay, I'll just refresh the slides just in case something else is added. Okay, moving to the next one. Okay, now, okay, the voltage across a resistor, inductor, capacitor are 20, 15, 30. The resultant voltage in the circuit is, this is also straightforward. 20, 15, 30 are the voltages across resistor. So 20 across resistor, inductor ke across it is 15, and across capacitor it is 30. So first solve it vector wise. 30 and 15 will resolve into 15, and you still have 20 over here. So 15 and 20's resultant will be the net voltage of that circuit. What is 15 square plus 20 square? What is 15 square plus 20 square? 15, 20, 25 are basically, you know, your Pythagorean triplets. So this will be 25 volts. Perfect. Let's get moving to the next one. Straightforward. Glad to know that my marathon sessions have been very, very useful. Bensi, these are actually easy questions. Let me tell you, if you have been attending my marathon sessions, this was actually easy peasy, even if you had not studied too much of physics. In a DC circuit, the direction of current inside the battery and outside the battery are, guys, this is also straightforward directly. Theory points. So inside a battery, the current goes from negative to positive, but outside the battery, it goes from positive to negative. Makes sense? So negative to positive and positive to negative. Perfecto. Chalo. Moving ahead to the next one. Yes, I'm going to come for set 4 also. Hold on. After this, immediately, just few more questions to go, and that's it. We are coming to set 4. Just give me 5-10 minutes. The magnitude of field due to a point charge at distance r is this. Field due to a charged sphere at a very far away distance with a total charge q is given by. See, you should just use this formula. F is k, field is asked. Field is nothing but k q divided by r square. This was initial, but the charge was also 2q. So this was k 2q by r square. Second time, for the new field, the charge is how much? The charge is q, and the distance is r by 2. That's it. Just do the math. You'll get the answer. Just check this out. This will become 4. So this will become 4kq by r square, which is basically twice of the previous field. So hence option C. Perfecto. As simple as that. So first you are at distance r. Now the distance has been halved. Charge also has been halved. So what will happen to the new field? Direct formula. Moving to the next one. This also I did. This also I did. This was done in the class. This was done in the class. So guys, what are you realizing? If you stay with me, your J will also be easy. That's what you are realizing. So that's why I'm telling you, we are starting new series for you this coming week, and make sure you attend it so that you can crack JEE Mains in the first attempt, and then you can start focusing on JEE Advanced as well. Okay, so this was done in the class. So horizontal is given 0.2, total is given 0.4. This is your right angle triangle. What is this theta? Your cos of theta is 0.2 by 0.4, which is nothing but half. So theta is how much, guys? 60 degrees, right? That's it. That's the answer. Perfecto. Moving ahead to the next one. The current in the primary coil changes from this to this. This was also done in the class. Mutual inductance is this much. So what is the induced EMF? This was done again in the class, in the marathon session. So EMF is, what is this? M di by dt. So M is known. What is M? M is 0.5. Change in the current is 7 to 3, which is 4. Time taken is 0.04. Just do that. I think you should get this as 50. Yes, you should get this as 50 volts. Perfecto. Moving ahead to the next one. Let's go ahead. Square sheet. This was also done in the class. Z plane, XY plane. In a at a coordinate z is equal to a, the field is this much. What is the flux in that region? So for this question, understand it's in parallel plane to xy. So the field which is there, which will go in the z axis. This is E along z axis is C z square into k hat, but z over there is A. It's mentioned z is A, so just put z as A. That's it. You will get it. And the side length is A. So the flux, which is field into area, the field will be C into A square. Area will also be A square. So CA raised to 4. That's option A. Perfecto. Got it? Chalo. Let's get moving to the next one. 3 charges Q, minus Q and Q naught are placed as shown in the figure. The magnitude of the net force on the charge Q naught at point O is, come on guys, this was straightforward. On Q naught, this Q is going to apply a repulsive force and this is going to apply an attractive force. So the resultant will be here. And if this one is F, this one is also F, the resultant will be F root 2, correct? So what is F then? F is K, Q, Q naught by A square. That's it. K, Q1, Q2 by distance square. That's it. It will be root 2 times. As simple as that. Moving ahead to the next one coming up on your screen. So there is a 3 nanocoulomb charge Q which is initially at rest. Distance of R1 is 10 centimeter from a 5 nanocoulomb charge Q which is fixed at the origin. Okay, so I'll try to visualize the situation. There is a charge at the origin which is basically 5 nanocoulomb, and then you have another charge at a distance of 10 centimeter. So that is capital Q. Which is 3 nanocoulomb and the distance is given to be 10 centimeter. Now you move it to a new distance of 15 centimeter. So basically you have found a new distance and that is 15 centimeter. So the question is, what is the work done? Guys, this kind of question also I did this in the class. The work done is change in potential energy. So final minus initial. So final will be K, Q divided by R2 and this will be K, Q divided by R1. So K, Q is common. 1 by R2 minus 1 by R1. Everything you know. K value you know, Q you know, Q you know, R2 you know, R1 you know. So the only thing you need to find out is work. Got it? Perfect? Yes. This is set 4 only, guys. This is set 4. But I'm guessing set 3 also had same question, set 3 to 1. Guys, confirm this to me. Yep. Very good, Harshita. Well, yes. Hello, MR Prince. Were the questions similar in set 4, 3, 2, 1 of SSJ2? If your code name was SSJ2, then I think the questions were same, SSJ2. Okay, most likely. Just check this out. Okay, next one. Car battery is charged by 12 volt. Energy stored is this much. Charge passed through the battery. So what is the charge passed through the battery? What will you do, guys? Okay, so the energy stored. The power is nothing but EMF into current, and what you can do, power is nothing but energy per unit time. This will be equal to EMF. Current is charge by time. So time goes. So energy is EMF into charge. So you know the energy, you know the EMF. The only thing you do not know is charge. That's it. Got it? Acha, there was SSJ4 also. Oh my god. Acha. So let's see. I have 2 papers with me. Okay, I'm going to solve both of them. Okay, perfect. So this is how it was. That's the way to solve it. I hope you guys understood how to solve this particular question. Yep. I'm going to come to SSJ1 also. A straight conducting wire of length L, mass M, suspended in horizontal plane by a pair of flexible strings in a magnetic field B. To remove the tension in the supporting strings, the magnitude of the current in the wire. Guys, visualize the situation. These are the 2 wires. This is the rod. Okay, this is how it is suspended. Now the question says that if you want to remove the tension, if this tension is 0, this tension is 0, then mg force must be balanced by a force of magnetic field. And what is the force of magnetic field, guys? Force of magnetic field will be ILB. So ILB should be equal to mg. So basically what will be the current? The current will be nothing but mg by lb. Got it? As simple as that. As simple as that. Okay, so very easy. Moving to the next one. Constant current is flowing, iron rod is inserted. Which of the following quantities will not increase? Very important, will not increase. Magnetic field at the center, yes, it will increase because you are adding iron rod. So iron rod will improve the permeability of the material. Okay, that medium will increase. So because of that, the field, everything, inductance will increase, flux will increase, this will increase, self-inductance will increase. Rate of heating, what has rate of heating got to do with it? This is wrong, guys. So A, B and D is the correct answer. Perfect. Let's get moving to the next one. A circuit is connected to an AC source of variable frequency. As the frequency of the source is increased, the current first increases and then decreases. Which of the following combinations is most likely? I gave this graph to you and I told you that resonance, you should remember the graph in my NCERT sessions. It looked like this. So this was current, this was maximum current, and this was your frequency. So if the current increases and decreases, obviously it is LCR circuit. It is LCR circuit. I mean, really they asked this. Okay. Chalo, let's move ahead to the next one. If N, E, tau are having their usual meanings, the resistance, this was direct formula. This was done. This was direct formula, guys, from, NCERT. I made you underline these things. It was there in NCERT. If you had to remember this, okay, just that's it. Remember that formula. Next, proton and alpha particles move in circular orbits in a uniform field. Their speeds are in the ratio of this, the ratio of the radii. Okay, this also was very easy. R1 by R2. You have to find. So R is mv by qb. If R is mass into velocity by qb, that's it. This is proton and alpha particle. So R1 by R2 will be m1 by m2. Speeds v1 by v2, charges q2 by q1. Because it is proton and alpha, so proton's mass, if it is 1, alpha particle will have 4, so 1 by 4. Speeds ratio 9 by 4. Charge ratio, proton if it has plus e, alpha has 2e. So, but this is inverse ratio, so this will be 2 by 1. 2 by 1. So that's it. Just check this out. So 9, I think that 2 will get cancelled. So 9 by 8, correcto. That's the answer. Perfect. Moving ahead to the next question. Okay. Sir, question video was alone enough. Many questions from my session came. I know, Dhanush. That's all. I mean, like, I'm very happy about it. And you guys are, I'm very happy for you. Not for me. I'm very happy for you that so many questions came and you attended my classes. That's it. Okay. So a coil of area 100 is kept at an angle this much in a field of this much. The field reduces to 0 in this much. The induced EMF. These questions also were done. EMF is change in flux by time. Change in flux is final field into area minus initial field into area divided by time. So this will be final field minus initial field. Take the magnitude, divide it into area divided by time. Do you know final field? Yes, 0. Do you know initial field? Yes, it was 10 to the power minus 1 Tesla. So you know this quantity. Area, I think you know this. Area also you know. And time, yes, that also you know. But there is one small catch over here. You need to also multiply this entire thing with cos of 30. Okay, with the coil of area is kept at an angle of, what is this, cos 30. Yep. So many of you might have missed this part. How many of you missed this cos 30 part? Because it is kept at an angle of 30 degrees with the magnetic field. So be careful about it. Okay. Chalo. So that's one thing. And somebody was asking, sir, in the previous question. Okay. Yeah, very good, very good. Some of you missed it actually. Oops. So Rahav Krishan, just use this formula, bacha. Just remember one thing. R is mv by qb. Velocity ratio is given. Proton has a mass of m. Alpha has a mass of 4m. If proton has a charge of q, alpha particle has a charge of 2q. Double the charge. That's it. So now just divide it, you will get the answer. Okay? Chalo, let's get going. Acha, but here in this question, there was one catch. The coil's area is kept at an angle of 30 degrees. Does that mean that this area vector is making 30 degrees with the magnetic field, or the coil's area is making? So which angle is 30 degrees? I think this angle is 30 degrees. So actually speaking, then the area vector will make 60 degrees. So technically speaking, in that EMF which we found out, where I wrote BF minus BI into area divided by time into cos, this should not be 30, this should be cos 60. Just check this out. Just check this out. Yep. Just check this out. Okay, who is this? Sukanya. Sukanya is saying, sir, cos 60 aayega. Definitely aayega cos 60, because the area vector will make 60 degrees angle. Okay, just check this out. Okay, cool. What is this? 15 ohm resistor and 80 millihenry inductor and a capacitor of capacitance are connected in series with 50 hertz source. The source voltage is given, current in the circuit are in phase, then the value of the capacitor is. This is the most important line. If they are in phase, that means it is in resonance. It is in resonance. That means the frequency is 1 by 2 pi root of LC. So check this out. Frequency is given. Done. Inductance is also given, 80 millihenry. So the only thing you do not know is capacitance. This is the formula that you need to use. Okay, cool. Very good. Very good. So the capacitance will be found out by this formula. That's the only thing you need to use. Perfect. 127 microfarad. Very good. 4 objects W, X, Y, Z, each with charge plus Q, are held fixed at 4 points in a square. Okay, and side is given. Objects X and Z are on the midpoints. Fine. Electrostatic force exerted by W on X, is F. Okay, this is F. Okay, so the magnitude of the force exerted by W on Z will be how much? So first thing that you are going to find out is the distance. This is just a question on distance. Guys, you can clearly see, if this is side length D, this is D by 2, this is D. So first figure out this hypotenuse. So this hypotenuse will be root of D square plus a D square by 4, which is D common. Outside 1 plus 1 by 4, which is D. 4 plus 1 is root 5 divided by 2. So once you know that, you just have to find out the magnitude of that force. So the force will be K Q divided by hypotenuse square. So substitute it, you will get the answer. As simple as that. And remember one thing, this is the new force. The old force was K Q divided by D by 2 whole square. So that's the only change. Here you will put D by 2, here you will put D root 5 by 2. That's what you are going to put over here. Okay. Yes, I'm going to discuss all the sets, Jaisil, don't worry. So this is SSJ2 set 4. Okay. Moving ahead to the next one. Two sources, equal EMF connected in series. This combination is in turn connected to external resistance. Internal resistance of the two sources are this much. Potential difference across the source of internal resistance R2 is 0. Then R equals 2. So basically two sources of equal EMFs are connected in series. Fairly enough. This combination is in turn connected to external resistance. Okay, something like this. Okay, perfect. And the internal resistance is R1, R2. This is E, this is also E. The question says that if the potential difference across the source of internal resistance R2 is 0, so that means this voltage is 0, then what is the value of R? What are you going to do? First of all, understand the total current in the circuit can be found out. There will be some current flowing in the circuit. You can find the current. what will be the current? It will be E plus E divided by R plus R1 plus R2. Total EMF by total resistance. Now this is 0. I have told you voltage across a battery, the voltage across a battery is given by E minus IR, and this is 0 according to the question. So E you know, I you can find it out from here, substitute it, solve it, and you will get the answer. Understood? That's the only catch. Okay, got it? How many of you got this answer then? Okay, see if you are getting this, option B. Yes, very good, very good, very good. Let's get moving to the next one coming up on your screen. Okay, which of the following statement is correct? Yes, magnetic field lines do not form closed loops. Correct. Okay, which of the following statements is correct? Magnetic field, oh, do not form closed loop, that is wrong. It does not form closed loop, that's wrong. Magnetic field lines start from North Pole, end at South Pole, that is also wrong. Then tangent at a point on a magnetic field line represents the direction. No, a tangent represents the direction of magnetic field at that particular point. Two magnetic field lines may intersect each other. Okay, so this is also wrong. This should have been correct. I think why D has been mentioned, this should have been C, guys. Okay, just verify this. This should be C, not D. Okay, I'll get it corrected. Maybe this was printed wrong over here. Okay, I'm just going to move this aside. Okay, I don't know whether I can move this. Yep, D. Wow, beautiful. This is the way I can move it. Magically, I have changed the answer. Okay, so this should have been C. Yep, B is not correct. Magnetic field lines do not start. They continue even inside the magnet. If this is the North Pole, this is the South Pole, do not forget, they continuously go in closed loops. They do not start from here. There is no start, there is no end. They appear to start. They appear to start from the North Pole. They do not end at South Pole. They continue its journey even inside the magnet. Okay, so hence C option is correct. Okay, next, the equivalent resistance between A and B of the network as shown in the figure is, okay, now first of all, do you see that there is a wire connected over here? And yes, correct. So there is a wire connected here. So don't you see this is completely useless? Why is this useless? The voltage difference across these 2 points will be 0. So there will be no current flowing through this. So only these two resistors are basically in series. So if they are in series, what will be their effective resistance? 2 ohm. As simple as that. So Karthik, according to me, the paper is looking very, very easy, and it will be even more easy, I will tell you, if you attended my sessions. That's it. Okay, next. So guys, those of you are attending little bit late, right now this is SSJ2 set 4. I will then go to SSJ1 set 4. Okay, so that will cover everything, I believe. All the sets will be covered then. Bar magnet is placed, initial position is parallel to the direction of the field. Acha, so basically M is parallel to the field, and in this position the magnitude of the torque R. Guys, torque, I just gave you this in my formula revision session, and potential energy is minus M dot B. Minus M dot B. Initial position is parallel to the direction of field. In this position, the magnitude of torque and the force acting. Force is always going to be 0. Torque is also going to be 0. So hence option C. Okay. Next question. A 300 ohm resistor and a capacitor of this much are connected in series to this much AC source. The current in the circuit is, okay, so what do we have? We have a resistor, we have a capacitor in series. Okay, resistor we have capacitor connected to AC source. Okay, and the current in the circuit. So in order to find the current, I think we need to find the total reactance. How do you find the reactance? The resistance is 300 ohm. Okay, then the reactance, the capacitive reactance will be a 1 by omega C. Okay, and omega is also given. Omega is nothing but 2 pi f. F is nothing but 50 hertz, and capacitance is 25 by pi. From this you will find XC. Then from that you are going to find Z, which is root of 300 square plus whatever you get from here, like this pi and this pi will get cancelled. 5 2s are 10, 100, yeah, 2/5, yeah, just check this out. Are you getting, this is 100 into 25, but that is microfarad, so that is going to be into 10 to the power minus 6. So you can do that calculation, put it here. From that you are going to find the current. Current will be the voltage. Voltage is 200 divided by Z. Just check this out. This is what you're going to do. See if you guys get it. Okay, perfect. All right, let's get moving. So Zeph, we are just giving you the idea of all the questions right now. Okay, if you want, we'll also post the detailed solution later on. All right, don't worry about it. For now, I just want to discuss the questions so that you are satisfied, yes, whether it is correct or not. The core of a transformer is laminated to reduce the effect of, guys, the core, when it is laminated, what happens? Eddy currents, losses are prevented, because the core which is there, the moment you apply some lamination over that, what you will see, the field which can penetrate through the lamination will reduce. So the magnetic field which can penetrate and enter into the core will reduce. So the changes of magnetic field are less. When the changes of magnetic field are less, by Faraday's law, EMF produced is less, current is less, heat is less, losses are less. So that's the flow of events. So eddy current losses, the heat losses which are created by induced currents are prevented by laminating it. Okay. So assertion reason questions coming up on your screen. 45 to 49 questions are assertion reason. Just check this out. A negative charge in an electric field moves along direction of electric field. Well, okay, that is, I'm pretty sure it is wrong. On a negative charge, a force acts in the direction of the electric field. Guys, both are false. We know that force is charge into field, correct? If Q is negative, then the force is anti-parallel to the field. It's anti-parallel to the field. Okay, so that's it. I hope that is clear. Very good. Yes, I'm going to come to the other set also. I'm going to come to the other set. Next question coming up on your screen. The poles of a bar magnet cannot be separated. Okay, and then we have magnetic monopoles do not exist. Yes, this is always correct. No matter what you do, if you take a north pole, south pole, this is a bar magnet, you divide it, you will again get north pole, south pole, and again you will get north pole, south pole. You again divide it, you will get smaller bar magnets, north, south, north, south. So you can never separate it. That is correct. Magnetic monopoles do not exist. Only they exist in dipoles. Next, when the radius of a current carrying loop is doubled, when the radius of a current carrying loop is doubled, the magnetic moment becomes 4 times. Well, let's see. Magnetic moment is NIA and NI area is pi r square. So if r is made 2 times, r square will become 4 times. So that is correct. The magnetic moment of a current carrying loop is directly proportional to the area of the loop. Correct. It is directly proportional to the area of the loop. That is also correct. And that's the reason for that. Yes. So assertion is correct. Reason is correct. And it is the correct explanation. Going ahead to the next one. Yes, I'm going to solve the set 4 also. Don't worry. Okay. So higher the range, lower is the resistance of the ammeter. Higher the range, lower is the resistance of the ammeter. And let's see. If the range is higher, then what happens? Through the galvanometer, hardly any current will flow because the shunt is having low resistance. So that is why most of the current will then end up flowing through the shunt, and that will increase the current. High current can then flow through the low resistance. Correct. To increase the range, additional shunt is added in series to it. This is wrong. This is wrong. You add additional shunt, but not in series. You add parallel to reduce it, not in series. That is wrong. So definitely R is false. Next question coming up on your screen. A step-up transformer cannot be used as a step-down transformer. Well, there is a problem. A step-up transformer cannot be used as step-down transformer. Transformer works only in one direction. This is wrong. Both, I think both should be false, guys. Okay, this should be D, I believe. A step-up transformer cannot be used as a step-down transformer. So this is not C. This should have been D. Both are. Sorry, my bad. Assertion is correct. One second. A step-up transformer cannot be used. No, it can be used. So this is wrong. A transformer works only in one direction. This is also wrong. So both are false. So it should be D option. D option should be correct. Okay, cool. Yes, I will just change the answer key as well out here. Just one second. Okay, right over here. So that's how I change it. Okay, let me just move it. Oops, my goodness. Is there an undo option somewhere over here? I don't know. Well, let me just try this. Okay, I'll just change it. It should have been D. Okay, just trying to change it. Okay, please come. Okay, it's not coming. Okay, just ignore, guys. I'll probably try to change it later on. Otherwise, if I can do it, I'll do it right away. Okay, perfect. Cool. Great. Okay, so this is the answer. Okay. एक क्वेश्चन के लिए 0.77 marks. Moving ahead to the next one. Okay, what do we have over here? Yes, this is done. Equipotential at large distance from a collection of charges whose total sum is not 0 r. Just check this. Is this your passage question or something? Equipotentials at large distance from a collection of charges whose total sum is not 0 r. Spheres, equipotential surfaces at a large distance from a collection of charges whose total sum is not 0 r. Planes, ellipsoids, paraboloids. Well, if you have a collection of charges, plus, minus, plus, minus, minus, plus, 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 and if you go very far away from it, when you go very far away, then this collection of the charges will tend to become a point charge. And when you have a point charge and you are very far away, then the equipotential lines will look something like this, because it's going to be a sphere. So it is going to be a spherical surface because the field lines are going to be like this, and equipotential lines will be spherical in nature. Option A. Very good. Let's get moving to the next one. 4 charges are given and are placed at the corners of a square as shown. The electric potential at point A midway between the 2 charges. How do you do this? Okay, first of all these charges are given. The potential is asked at this point. So first point, potential due to this and due to this, and then due to this and then due to this. So you will have 4 terms. K, Q divided by this distance will be L plus K, Q divided by L, and then you will have 2 negative terms because of this guy and this guy. So you need this distance. So think about it. The horizontal line is 2L. This is L. So this one over here will be root of 2L whole square plus L square, which is L root 5. So this will be K Q by L root 5 minus K Q by L root 5. Just check this out if you are getting this. Everybody clear about this? Are you getting this as the option? Option A. Perfect. So that's all you need to do. Potential due to this, potential due to this, potential due to this, potential due to this. This length is L. This you find it out by Pythagoras. That's all. And just add the potentials. The negative signs have come because these 2 charges are negative. So I think I can already see there is 2 over here because it comes 2 times. This also comes 2 times. Perfect. Next, case study. Experiment was set up with the following circuit diagram. R1 is 10, R2, R3 is 5. R is 0 ohms and E is 5 volts. The points with the same potentials are, okay, the points with the same potentials are, you can see B, C, D, no. B and C are at the same potentials. A, B, C are at the same potentials perfectly. G, F, and H are also at the same potentials. Okay, and yes, so I think F, H, J, no, J, yes, J also, because it's also part of the same wire. So it's a part of the same wire. So all these conducting points will be at the same potential. Perfecto. So yes, I think option B is correct. Yep. Even ABC would have been correct, but ABC is not there. Okay, don't worry about it. The current through the branch BG is, the current through the branch BG is, see, look at this question. The current through the branch BG is how much? Okay, so through BG, BG means this much. How are you going to find? Well, this resistance is as good as not there. These are two resistors. R1 is 10 ohms, R2 and R3. R2 and R3 each are 5 ohms. So basically you have R1 which is nothing but 10 ohms, and then you have R2 and R3 together. R2 and R3 together you will get 5 plus 5, which is also 10 ohms. So both of them are essentially connected now in parallel across that battery. What is that battery? Battery's voltage is 5 volts. So what is the effective resistance of both of them, guys? What is the effective resistance of this circuit? 10 and 10 in parallel. So if 10 is parallel to 10, the effective resistance will be 5 ohms. So what will be the current in the circuit? The current in the circuit will be 5 by 5, which is 1 ampere. So 1 ampere will get divided in both the branches. Half amperes will go here, half amperes will go here. So hence the answer will be whatever, half amperes. Yes, option C, correcto. Excellent. Let's get moving. The power dissipated in R1 is, the power dissipated in R1 is, where is R1? Okay, so once I know what is the current over here is 0.5 amperes. R1 is 10 ohms. So power will be I1 square into R1. So I1 is nothing but 0.5 square, R1 is nothing but 10. So 0.5 means 1 by 4 into 10. So this is nothing but 5 by 2. That should be the answer. 5 by 2 watts. Just check this out. 5 by 2 means 2.5 watts. Yes, correct. Yes, perfecto. Last question, I think the potential difference across R3. The potential difference across R3. Where is R3? R3 is over here. We just saw that the currents get divided equally as half amperes. So the voltage difference over here will be IR3. Current was half, R3 was how much? 5. Yep. So 5 by 2, which is again nothing but 2.5 volts. That's the answer for that particular question. Yep, perfecto. Yeah, is it C? Yep, it is 2.5 volts. Perfect. Okay, so let's do the next set. Just I will arrange the questions. Just give me like 5 minutes. Okay, are you ready with yeah, just call up all your friends. Just be ready. Within 5 minutes I will come back. Just 5 to 6 minutes. I'll just take more, probably 7 minutes or 5 minutes, and I'll be back. Okay, just give me some time. I'll just arrange the questions and come. Hello, hello. Yes, my warriors, can you hear me loud and clear? Welcome back. Yep. SSJ1 ready to discuss? Do let me know and mark your attendance by putting up a yo, putting up a heart, putting up a smiley in the chat box. Do let me know if you guys are here. I just saw if the set has come or no. I think the set has just come, and I'll just refresh this so that it gets loaded. All right, just 1 second. Okay, I'll just load this again. Perfecto, perfecto, perfecto. Let's get going with the set 2 discussion, or the whatever the other set, SSJ1. Okay, this is SSJ1, and let's get going. Yes, welcome Fazil, welcome Anli, welcome Jyotsna, VSK, Sayana, welcome Mamatika, welcome Muzamil, welcome Sakshi, Sri, Chess, Rapu, welcome Jeffrey, welcome aboard. Okay, electric dipole placed in non-uniform field will experience, guys, this was just done in my class. What will it experience in a non-uniform field? If imagine this is positive, this is negative, one force will be more, one force will be less. This F1 and F2 will not be equal. So obviously there will be torque and the net force will not be 0. So hence net force and torque. Perfecto. Done. Next, N1 be the number of field lines from a cube which encloses point charge 2q. Okay, so we have a cube like say for example, and it has 2q charge, and there are N1 lines coming out of it. Now we have N2 lines coming out of a sphere from a charge of 3q. So this has N2. Guys, what is this number proportional to? It is proportional to the flux. And what is flux proportional to? Flux is proportional to the charge. So basically I think N1 by N2 will be Q1 by Q2, which is nothing but 2 by 3. So 2 by 3 should be the answer. Perfecto. That's it. Number of lines proportional to flux. Flux is proportional to the charge. That's Gauss's law. As simple as that. Moving ahead to the next one. Guys, there was no significance of cube and sphere. If you thought, sir, sphere, more surface, less surface, it's got nothing to do with it. As long as it is closed, you know, the number of lines is directly proportional to the charge inside. Complete application of Gauss's law. That's it. Okay, in this circuit, P and R are not equal, but the reading is same with the switch open or closed. That means it is a balanced bridge. That means it is a balanced bridge. And if it is a balanced bridge, what happens, my dear warriors? Then, you know, this, there is no current which is flowing over here. There is no current which is flowing over here. So whatever current goes here will flow through this. Whatever current goes here will flow through this. So R and G will have the same current. P and Q will also have the same current. So R and G same current. I can see that here. P and Q is not there anywhere. So otherwise that also would have been true. IP is equal to IQ, but it is not there. R and G will have the same current. Makes sense. Perfect. Just based on balanced Wheatstone's bridge. Two wires, A and B of the same material, having length in the ratio 1:2 and diameter in the ratio of 2:3, are connected in series with a battery. Okay, the ratio of the potential differences across the two wires is, guys, whenever you have two resistors in series and connected across a battery, this is V1, this is V2. V1 by V2 will be IR1 by IR2. Current in them is the same. Resistance is rho L by A. So rho 1 L1 by A1 divided by rho 2 L2 by A2. Clearly materials is same. So rho 1 and rho 1 gets cancelled. Lengths are in the ratio of 1:2. Areas in the ratio 2:3. So that means 3:2 will come over here. So 3 by 4 should be the answer. Perfecto. Acha. Maybe guys, I am getting the feeling that maybe there were two sets like this and there was set 1, 2, 3, 4 in that. Was it like that? Just check this out. Maybe SSJ1 only was there, but the order, the arrangement of the options was different. Was it like that? Just check this out. Okay, moving ahead to the next one. Two galvanometers have the following characteristics. Turns are given, area is given, field is given, spring constant is same, ratio of the current, sensitivities. I just gave you this formula. Current is basketball, which is NBA, divided by torsional constant, captain, into theta. So I by theta is basically, which is the sensitivity. Sensitivity is just NBA by K. So sensitivity 1 by sensitivity 2. Since K is the same, it is given, spring constant is same. Therefore, it will be N1 B1 A1 divided by N2 B2 A2. Everything is given, NAB. Okay, just check this out. All right, perfect. Let's get moving to the next one. Fourth question is fine only, bacha. It is 3 by 4 only, nothing. Indrani, what happened? What just happened? The ratio of the potential difference, what was the problem? Everything was fine over here. V1 by V2 will be R1 by R2. It will be L1 by L2 into A2 by A1. Correct. L1 by L2, the ratio of the diameter and the having lengths in the ratio this. Okay. 1 second. Let me just do this again. L1 by L2 is 1 by 2. Correct. A2 by A1. Acha, this was diameter. Acha. So area will be in the ratio 4:9 because area is proportional to the square of the radius. Okay. Yes. Correct. This was diameter, not area. So area will be 4/9. So basically when you substitute it over here, 4/9 over here, this should be 9/8. Yup, this should be answer D. Okay, this is answer D. My bad. Thank you very much. This is answer D. Perfecto. Correct. Chalo, let's get moving ahead to the next one. Okay. Here we have, okay, this is done. Moving ahead. A current I is flowing through the loop as shown in the figure. MA is given, MB is given 2 times the radius. The magnetic field at the center of the loop is given by. Okay, so here this is basically 3/4 and this one over here is basically 1/4 of the complete loop. Now the field due to the 3/4, the field due to that will be mu naught I by R. Fair enough, but multiplied by 3/4, mu naught I by 2R into 3/4. Why 3/4? Complete circle will give mu naught I by 2R. 3/4 of it will give 3/4 of that complete field. Then what will happen over here? For the second one over here, B2 will be calculated by the field of 1/4 of a complete coil. So complete coil will have a field of mu naught I by 2 into 2R. Why the 2R? Because the radius is 2R. Perfecto. And into 1/4. That's it. Now total them up and you will get the answer. Okay, just total them up. And you can see it is inside the plane of the paper. It will be inside the plane of the paper because the current is going like this. B will be inside of it. Just check if you got 7/16. Yes, Banish, 4 का D होगा. 4 का perfectly D होगा. Okay, don't worry. Yes, perfecto. Just add them up and you'll get the answer. 7/16. Next question. Capacitor, inductor connected in 2 different AC circuits. Okay, with a bulb glowing in each circuit. The bulb glows more brightly when turns are increased, the separation between the plates is increased, iron rod is induced, dielectric is induced. Okay, so what do you need to do over here? See, capacitor and inductor are connected in a AC circuit. So basically inductor is there, capacitor is there, resistor is there, and this is AC. So if there is more current, then the bulb will glow more brightly. So this means current is more. How do you increase the current? Z is less. Impedance has to be reduced. How do you reduce Z? Z was root of R square plus XL minus XC whole square. How do you make Z less? By decreasing XL or increasing XC. Can you see that? By decreasing one of them. Now what is XL? XL is nothing but omega L. XC is nothing but 1 by omega C. Okay, if you increase the inductance or you add some rod in it, then you will end up increasing XL. So obviously this is ruled out, this is also ruled out. If the separation is increased, then capacitance will decrease. So that is also ruled out. See, if you add dielectric, capacitance will increase, XC will decrease. If XC decreases, then that also can create a problem. Okay, I'm going to get back to you on this. Just let me check this out. Either all the options are wrong, then it becomes a bonus. I will just get back to you after some time. Okay, I'll post it in the Telegram channel. Okay, if there is some problem in this question, I'll get back to you, because all the options are seemingly wrong. All the options. A pure inductor of 318 millihenry and a pure resistor of 75 ohm are connected in series to an AC source. The voltage across the 75 ohm resistor is found to be this much. The source voltage is how much? Okay, so pure inductor is there, pure resistor is there in series. The voltage across the resistor, 75 ohm resistor, is 150 volt, and the question is the source voltage is how much? Okay, fair enough. And you have an inductor right over here. That's the question. Okay, so first of all, let's see what we can do. We know the frequency, we know the inductance. So this is 318 millihenry and the frequency is 50 hertz. Now from this you can find out XL, inductor's resistance, which is nothing but omega L, which is 2 pi into F into L. Once you know XL, what you can do is find out the Z. What is Z? Z will be R square plus XL square. Once you get Z, then what you can do, yes, once you get Z, yep, the voltage is known, and yes, this current is also known to me, because look at this, 150 volts is current into resistance 75 ohm. That's it. So this clearly tells me current is 2 amperes. That's it. Once I know the current is 2 amperes, what I'm going to do is the total voltage of that source, will be the current into the impedance. So what is the current? The current is nothing but 2 amperes into Z. Z I have found out from here. So once you substitute, then you will get the final answer. So looks like a much lengthier problem than your usual one. So first, because omega is given, L is given, you find XL. From XL you find Z. Current you find it out from V is IR, which is 2. Then voltage of the source is I into Z. So those are the steps to solve the question. Correct. And you should get around 250 volts. Moving to the next one. The potential at a point on the axis of a short dipole at a distance x from the midpoint of the dipole is proportional to. Remember, this is potential, and I had told you potential will be, some constant will be there, and you will have R square. That constant is nothing but you will have, what is this? Electric dipole. So K into P into cos theta. Kp cos theta by R square. So R square means X square should be there. D option, that's direct formula. Moving to the next one. Okay, F1 be the magnitude of the force between two small spheres charged to a constant potential in free space. Okay, and F2 be the magnitude of force between them in a medium of dielectric constant K. Then what is the value of F1 by F2? So see guys, if F1 is the force in free space, F1 is the force in free space, the moment you add it in a medium, then the force will become less. So F2 will be F1 by K. So basically F1 by F2 will be K times. So in a medium, we all know that the force reduces K times. So This is the medium, this is space, free space, so it reduces by k times. That's it. So hence B. Infinity resistance in a resistance box has a resistance. So when I say the resistance is infinity, it means there is a gap. So that gap is nothing but air. And what is the resistance of air? Very, very, very large. So it is as good as infinity. So that's it. Perfecto. This is a gap only. Moving to the next one. Okay, there we go. The battery of 15 volts and negligible internal resistance is connected across 50 ohm. The amount of energy dissipated as heat in the resistor in 1 minute. Okay, this is straightforward. So we have power is equal to V square by R. So H will be the amount of heat will be V square by R into time. Voltage is known, 15 square. So R is 50 time 1 minute. That means 60 seconds. So just do the math and just see if you are getting it. Come on guys, are you getting it as 270 joules? Very good, very good. Perfecto. Moving to the next one. Lenz's law is the consequence of the law of conservation of energy, charge, mass and momentum. We all know that Lenz's law basically talks about back EMF. Basically the opposing EMF which opposes the changes in the flux. So it is all based on conservation of energy. So, you know, whenever you change the flux, there is an opposing flux to reduce that change. So it is completely based on energy principle, not on charge, mass or momentum. The vertical component of the field at a place is √3 times the horizontal component. Okay, so we have the vertical component. The vertical component is 1 by √3 times the horizontal. So this is the horizontal. Okay, so the question is, what is this theta? So clearly you can see tan theta is 1 by √3. So that is it. So that means theta is 30 degrees. So that is option B. Correcto. Done, done. Yep. Very good. Moving ahead to the next question. A long wire in the horizontal plane carries this much current north to south. The magnitude and the direction of the field at a point 2.5 meters east. So it carries from north to south like this. So if you hold your thumb down, the fingers will curl like this. So 2.5 meters east. So on the east side means it will come towards you. It will come towards you. This is upwards. Remember, this is north, this is east, this is south. So it will come upwards. So obviously these two options are out, and the only way you can find this field is by this formula, mu naught I by 2 pi r. Mu naught I by 2 pi r. Okay, just check this out. If you guys got it as 1.2 micro Tesla. Everybody, let's get moving to the next one coming up on your screen. So these are the formulas that you have to use. Let's quickly discuss all the questions because I know you guys are, yes, worried about your chemistry paper too. The EMF induced in a 10 Henry inductor in which the current changes from this to this in this many seconds. Okay, so EMF induced के लिए formula is L delta I by delta T. So what is the EMF induced is the question. L is 10, change in the current is 11 to 2. So 11 minus 2 divided by the time. Time is 9 into 10 to the power minus 2. 11 minus 2 is 9, 9 cancels, 10 goes on the top and it will become how much? 10 to the power 3, just check this out. 10 to the power 3 is looking correct. 10, oh sorry, this was 10 to the power minus 1. Oh sorry. So this will become basically 9 and 9 cools off. So it will become 10 to the power 2. Yes, option C is correct. Perfecto. Moving ahead to the next one. A charge Q is placed at the center of the line joining two charges. The system of the three charges will be in equilibrium if. Okay, so this is a standard question, Q, and you have Q over here. This is capital Q, and here this is the distance between them. They will be in equilibrium. Okay, let's say this is A, this is also A. How will they be in equilibrium? Obviously, think about it this way. This charge will experience some force because of this and some force because of this. If they cancel, they will obviously be in equilibrium. This will anyways be in equilibrium because these two charges will, anyways apply same magnitude force in the opposite direction. So essentially what should happen, the force on this charge by Q, and the force on this charge by small q should be equal. That's it. So it will be kq into q divided by 2a whole square. This should be q divided by a square. Just equate this and see if you are getting the answer. So from here only you can see the magnitude of q is coming out to be q by 4. This is what the magnitude of q, but it will be opposite in direction, so hence that minus sign. Hence the minus sign. Correct. Very good. Focus consistency. Okay, that's it. Perfect. Excellent. Let's move ahead to the next one. Electric flux of an electric field through an area. Guys, this is straight away definition. It's a dot product. E dot dA is going to give you the flux. Perfect. Moving ahead to the next one. In a potentiometer experiment, the balancing length with the cell is 120. When the cell is shunted by 1 ohm, the balancing length becomes 40 and the internal resistance of that particular cell. Guys, there is a direct formula. R is equal to R into L1 by L2 minus 1. This is finding internal resistance of a potentiometer via, finding the balancing length without the external resistance and with the external resistance. That's it. That's the formula. Very good, Sakshi. I had given you this formula in again NCRT underline. I gave you this formula exactly. So everything is known. So you know the new length, old length, you know the shunt resistance. This 1 ohm is basically this R. So this is what you have been asked. That's it. Done. Perfect. D. Very good. Achha, how many of you are getting full marks till here? 20th question. An electron is projected with velocity v along the axis of a current carrying long solenoid. Which of the following statement is true? Let's see. So basically you have a solenoid like this and you are projecting that electron along that axis. Even the field is along that same axis. So V cross B will be 0, force will be 0, so it will continue to move along the same path. Wow, Srijaya saying 100, chess and football saying 18 questions. Very good, very good. 1 marks lost says VSK. Wow, Rapu, almost full marks. Excellent. Sakshi also getting full marks. Very good. Proud of you till here. Acha, Manish, don't worry. Maybe in the next few questions you will get more questions correct. Very good, Farzeen. Okay, yes, so 1 question might be bonus. Let's see about that. Okay, all right. Okay, simple girl, I hope you get all the other questions correct. If the speed of a charged particle moving in a field is half, then the radius of the path will become how many times? Okay, so radius is mv by cube b. So speed has been halved, correct? If the speed is half, then the radius will also become half times. As simple as that. So hence the answer should be, okay, I don't know why it has been put up as C. The speed has been half and the radius will become half, guys. This should be the correct answer, not C. Okay, so I think I need to change this. Okay, I'll just change this right away so that when you get the PDF, you have the right answers. I'll just change it. Okay, I'll put it here. Perfect. Okay, 1 second. Okay, my goodness, take some time, but wait a minute. I'll just do this so that you have the correct PDF. Okay, perfecto. Let's get moving to the next one. Okay, here we go. A metal plate is getting heated. Which of the following statements is incorrect? It is placed in a space varying field, but it does not change with time. See, if it is getting heated, that means there is some current, and if there is some current, that means there is some induced EMF, and if there is induced EMF, there must be some change in the flux. That's what I can understand. So if in the first part magnetic field is basically constant with respect to time, then what will happen? The flux will not change. So why will there be any current? So obviously there will be no current and there will be no flux change, and there will be no induced EMF in the first case. If there is current or AC current passing through it, then there will be I squared R joules heating which will occur. And if it is placed in a time varying magnetic field, then magnetic flux will change, and that will cause EMF, and that will cause the current, and that will cause the heating. Perfecto. Next question coming up on your screen. Okay. Acha Vishnu, there were two separate circuits. Looks like I do not have the complete question then, Vishnu. Probably once I get the complete question, probably then I will be able to do that. Okay, just that's why I said just hold on. As soon as the session is over, I'll post the correct answer in our Telegram channel. In an AC circuit, the applied voltage and resultant current are this much and this much. The average power consumed in the circuit is, guys, this is straightforward. Look at the phase difference. The power factor will be how much? Cos pi by 2, which is 0. Hence the power will be 0. Power factor is 0. Khatam. The phase difference is 90 degrees. They are perpendicular. Cool? Very good. Next, the speed acquired by a free electron when accelerated from rest through a potential difference of 100 volts is... Come on. So guys, talk in a language which even I can understand. Even I want to be a part of the conversation. I keep looking at your chat box. Even I want to understand what you guys are saying. If you talk in Tamil or Malayalam, then probably I'm not going to understand this. Okay, so how do you solve this question? All you need to do is use half mv square is equal to charge of that electron into the potential difference. So V square will be 2E delta V by M. So V will be root of 2E delta V by M. So now you just substitute the values. E is 1.6 into 10 to the power minus 19. Delta V is 100 and mass is 9 into 10 to the power minus 31. That's it. Very good. Oh, Anjali Nair, it is Malayalam. Okay, I guess so. By the look of it. Okay. All right. So let's get moving to the next one. Were you getting 6 into 10 to the power 6? That's the answer. Moving ahead. Which of the following is not affected by the presences of the magnetic field? Current carrying conductor. Not affected by the presence of magnetic field. Current carrying conductor, moving charge, stationary charge, rectangular loop. Guys, current carrying loop, ILB force. Moving charge, QVB force. Stationary charge QVB, where V is 0, so hence QVB is 0. So a stationary charge will not be affected. Rectangular loop will be affected because again ILB, current carrying force. Yes, it will be there. Perfecto. Option C. Direct. Two charges are located at this location of the point on the x-axis where resultant field due to them is 0. So we have 16q charge over here on the x-axis. Let's say this is x equals to 0 and x equals to L. This is x equals to L. We have minus 4q. So the question is the point where the field is 0, resultant. So field due to this and field due to this should cancel. So field due to the 16q charge and the field due to the minus 4q charge should cancel each other. Just assume this as x, guys. So assume this entire distance as x. So this distance, how much will it be? It will be x minus L. Why is it x minus L? Because this much distance is L. So now just do the math. So the field should cancel. So if they cancel out each other, so what will be the magnitudes? K into 16q divided by x square should be equal to k into 4q divided by x minus L whole square. Now just do the math. You can see so many things will get cancelled. K, Q, 4, 16. Just do it. You should get the answer as 2L. Are you getting the answer as 2L? Yep. Wow, Sakshi, section A all correct. Perfecto. Oh, I don't know. Maybe it could be a previous year. I could see so many previous year JEE questions only asked. Was it 2L? Perfecto. Perfecto. So, very good. Let's get moving to the next one. There is a dipole of dipole moment this much kept in uniform field this much, experiences torque this much. Guys, this I did it in the marathon session. This was done in the marathon session already. So just use torque is mb sine theta. Torque is given, dipole moment is given, field is also given, only theta is asked. Very, very easy. Very, very easy. Was it 30 degrees? I can already see people asking 30, telling 30 degrees. Very good, and you guys remember it. Moving to the next one. 3 charges placed on the x-axis left to right with adjacent charges separated by some distance. The force on a charge nearest neighbor is F. So what is the net force on each charge from the left to right? Okay, 3 charges are placed on the x-axis. Let's say this is the x-axis, equal distance 1, 2 and 3. So let's say the charges are Q, Q and Q between any 2 neighbors, separated by distance D. So this is D, this is D. Between any 2 neighbors, the force is F. So F is basically K, Q, Q divided by D square. It is essentially K, Q square by D square. So what are the forces from on this charge and this charge? So let me call this 1, this is 2, this is 3. Obviously force on 2 is 0. Why? They will cancel each other. They will cancel each other. So is 0 there? Yes, here, here, here. So this option is ruled out. Okay. So now one side will be negative, one side will be positive. You don't even have to solve this here. See, think Q and Q will apply a force this way. This Q and this Q on this charge will apply a force this way. So if one is negative, other term should be positive, na? So is that option there? Yes, option C is there. Can you see negative and positive? Did you see that? Yeah, it's logic. Very, very logical. That's it. Khatam. Done, done. Move ahead to the next one. 2 students calculate the charge flowing through the circuit. One guy says 300 coulombs flows in 1 minute. Other guy says this much electrons flow in 1 second. Who is correct if the correct current is 5 amperes? Guys, just find this. This is like so easy. Charge flowing in the circuit is 300 coulombs in 1 minute. 1 minute is 60 seconds. So 0, 0, this will become 5. So you got 5 amperes. So A is for sure current. And for B, you have to just do 3.125 into 10 to the power 19 electrons. Each electron is 1.6 into 10 to the power minus 19 divided by 1. I don't think it comes out to be 5. Are you getting answer as A? Okay. Very good. Yes. Is it coming out to be 5? Just check this out. 1.6 into 3.125. Yes, it is coming out to be 5. Correct. It is coming out to be 5 amperes. So if it is coming out to be 5 amperes, who is correct? A is correct and also B is correct. So both A and B are correct. The number of electrons which are flowing, which carry 1.6 into 10 to the power minus 19 coulombs of charge, both. 30th question. Resistance of the 2 wires having same length, area, cross section 2 ohm and 8 ohm. If the resistivity is this, then the resistivity of 8 ohm is how much? Let's have a look at it. So resistance is, I can write it like this, R1 and R2 will be, because they are having different resistivity but same length, same area. So it will be rho 1, L is same, area is same, rho 2, L is same, area is same. So it will be basically rho 1 by rho 2. So now rho 1 is known. Rho 1 is 2.65 into 10 to the power minus 8. Rho 2 is unknown. R1 is 2 ohm. R2 is 8 ohm. So 2 by 8 is 4. So rho 2 will be 2.65 into 4 into 10 to the power minus 8. Just check this out. 2.65 into 4 should be close to 10. 10.6. 10.6. Just check this out. Are you getting it as 10.6? Yep. Very good. Getting it as A. Very good. Moving to the next question coming up on your screen. Okay. In a certain region, field and magnetic field are perpendicular to each other. Electron enters the perpendicular to the direction of both A and B and goes undeflected. Now, if it goes undeflected, this is a formula of crossed field. This is a formula of crossed field where electric field is here, magnetic field and velocity, all of them are perpendicular to each other, and this V should be E by B magnitude. E by B magnitude. So that is option C. Perfect. Perfecto. That's it. There we go. Next question. Test charge is moving with some speed and in a field, then the force on the test charge is. Guys, I think charge is given, velocity is given, field is given. What else you need? Force is Q, V cross B. Just do the cross product of these two. So all you need to do is 4I cap plus 3K cap cross 4B is 4I cap plus 3K cap and charge is 1.6 into 10 to the power minus 19. Just check this out. So remember, I into I is always going to be 0. So I into I is 0. K into K is also 0. I into where is it? I into K will be, look at this, I, J, K. I into K is minus J. I into K is minus J. Just check this out. Okay. So I into K is minus J and K into I is plus J. I think they will all cancel out. 4 into 3, 12. 3 into 4 also 12. So when I do 4 into 3, I cross K, I'm going to get minus 12 I cap, sorry, J cap, and 3 into 4. So the moment I do 3 into 4, I'm going to get plus 12 J cap. Everything is going to get cancelled. Just check if you're getting D. Just see if you're getting D. Yes, Mushabir, are you getting it? Yep. Yes, perfecto, perfecto. Just see if this is correct. Very good. Let's get moving to the next one. In a series LCR circuit at resonance, the current is equal to, in resonance, guys, at resonance, what happens? XL is equal to XC and VL is equal to VC. So the total voltage is equal to voltage across the resistance. Correct? Remember, and the total impedance is just the resistance. So the current, which is usually V by Z, will just become V by R. That's it. Option A, correct. Excellent. Excellent. So the impedances are calculated just by calculating resistance. XL and XC both are opposite and they are equal. That's how it is. Very good. Moving on. Frequency of an AC source for which 10 microfarad capacitor has a reactance of this much. Use this formula. XC is 1 by omega C. XC is given, so 1000, and omega, we need to find it in hertz, so 2 pi f, and the capacitance, which is 10 micro, which is 10 into 10 to the power minus 6. So move it over here. F will be basically 1 by 2 pi into 10 to the power minus 6 into 1000. Just do the math and you'll get the answer. Just do the math. See if you are getting this as 50 by pi. Just check this, 3 zeros here, 4 zeros. So this will become 10 to the power minus 2. So it will become 100. So yes, 100 by 2 pi, which is 50 by pi. See if you are getting this as 50 by pi. Yep, it is correct. That's the correct answer. Moving ahead to the next one. In the given network of capacitors, all are identical and each one is a capacitance. Which of the following is the equivalent capacitance between the 2 points A and B? Okay, so first of all, I don't know whether you see this. Actually, this much circuit is a standard circuit. This much circuit and this much circuit is a standard circuit. What are they actually? They are nothing but 3 capacitors in parallel. This is standard. You would have seen this again and again. You would have seen this again and again. Correcto. So this capacitances in parallel will become 3C. Now this 3C is again in series. Just check this out. Oh no, it is not in series. Now this is again extended. Oh, it's completely extended. Look at this. Look at this. It's completely extended circuit. So what we can do, check the potential. This is potential A. This is also potential A. This is, let's say, potential B. Yes, correct. We are fine. Yes, we are correct. So this is some other potential, let's say P. This is P and this is also P. Correct. So we have 3C in series with another 3C. Correct. This 3C is for this guy and this 3C is for this guy. 2 capacitors in series. So 3C by 2. Because capacitors in series, you add them like reciprocals. Perfecto. 3C by 2. It's in series. Correct. So that's the answer. Given figure shows IV graph for a copper wire whose length and area of cross section are given. The slope of this curve becomes less or more if the temperature is changed. Okay, let's have a look at this. The slope of the curve. So the slope of this curve is basically current by voltage. Now we all know V is equal to IR. So by that, this will become nothing but 1 by resistance, and 1 by resistance means it will be rho L by A. Okay, now look at this. If the length of the wire is increased, if you increase the length of the wire, if length of the wire is increased, what will happen? The slope will become less. It makes sense. If denominator increases, the slope will decrease. So yes, option A is correct. If more length is there, then slope will not increase. In fact, it is going to decrease. So B is obviously wrong, and all the other things will not make sense. I mean, once you get one answer, you can just move on. Moving ahead to the next one. Okay, cool. When a potential difference V is applied across a conductor at temperature T, the drift velocity of the electrons is proportional to. Okay, the potential difference is applied, the conductor is there, temperature T, the drift velocity is proportional to. Guys, remember one thing, current is NVDR, correct? And V is equal to IR. So V is equal to N drift speed E A into R. So the drift speed is directly proportional to the voltage. So you can see option C should be correct. Yep, option C should be correct. Perfecto. Moving ahead to the next one. 2 identical thick wires, 2 identical thin wires, all are of the same material and the same length, form a square in 3 different ways. PQR. Due to the current in these loops, the magnetic field at the center of the loop will be 0 in the case of. Okay, so the field will be 0 in what all cases? Let's think about it. Thick wires and 2 identical thin wires. Okay, see, if the current gets divided equally, then what will happen? The fields will cancel. I'll tell you how. See, look at this. Because of this current, the field is going to be inside. Because of that current, use your right hand thumb rule, it is again going to be inside. Now, check this out. Because of this current and this current, the fields are going to come outside towards you. If this current and this current are equal, then the net field will be 0. do you see that? The net field will be 0 if the currents get divided. You divide equally. You divide them equally. Now if you notice, this part and this part are equal, so they will be divided equally. Here it will not be divided equally. Do you see that? More thick wire, more resistance and all of that. Here this is fine. Even if thick comes first, doesn't matter. Thick, thin, doesn't matter. The order does not matter. So even here you are going to see equal division. This and this will be equally divided, and therefore over here they will cancel each other. Hence P and R only. P and R only. Perfect. Moving ahead to the next one. There is a circular current carrying coil produces a magnetic field B0 at its center. The coil is rewound so that to have 3 turns, the same current is passed through it. The new magnetic field at the center is. A current carrying coil produces field. Now what happens? The same coil is rewound. That means earlier the perimeter was 2 pi r. Now because you have 3 turns, understand this, the total length of the wire is 3 times 2 pi new r. It's old r, now the new r is going to be different. So in fact, the new radius will be the old radius divided by 3. You can see that right from here, 2 pi r, okay, has now changed into 3 into 2 pi r1. So once you get this, the old magnetic field was mu naught I by 2r. The new magnetic field will be mu naught I by 2 into, the r is going to be r by 3, but there are 3 turns over here. Do not forget to do that. Here there was only 1 turn, here there are 3 turns. 3 3s are 9. So mu naught I by 2r into 9. This is your old magnetic field. So it will become 9 times of the old one. Correct. So the turns have increased, radius also has decreased. So hence magnetic field has become 9 times. Moving ahead. Which of the following statement is true? Okay. Inductor has infinite resistance. Inductor and capacitance both cannot conduct. Capacitor can conduct in DC but not an inductor, and inductor can conduct in DC but not a capacitor. Yesterday only somebody asked me during the session, and I told you this, that XL is omega L and XC is 1 by omega C. So when frequency increases, XL increases. When omega is 0, XL is 0. Here understand, when omega tends to infinity, then XC tends to 0. So what does this mean? This part just refers to DC, because in DC angular frequency is 0, there is no oscillation. So for a DC, the inductor does not offer any resistance. So yes, in a DC circuit an inductor can conduct, but for a capacitor, understand, it will offer, oops, sorry, I think I have to put infinity over here. Yes, this was infinity. So the capacitor will offer infinite resistance. It will not conduct. It will not conduct, basically. So not a capacitor. Keep this in mind. So all the other statements, you can just rule it out. I hope that is clear. Yep. So, oh, it was you who asked that question. Yes, 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 yes. Correct. Very good. Let's move on to the next one. A magnetic flux linked with the coil is given by this much. This is in this t in seconds. Induced EMF at t is equal to 5. This was done in class. This was just done directly in the class. So EMF will be just the derivative of 5t square plus 3t plus 16. So this will be 10t plus 3. Just put the value of time as 5. So how much will it be? Just check it out. 50 plus 3, which is 53. That's the answer, option A. Perfecto. Let's get moving to the next one. Charge is moved against the Coulomb force of an electric field. Then what will happen? Work done by the electric field, work done by external source. Interesting. See, if you have a charge and you move it, the motion of that charge is against the force of the electric field. So this is where the force is. That means you are doing work on it. This is the electric force. the motion is like this. So work done by the electric force is going to be negative. If you are moving it like this, the external force will be like this. So the work done by external force will be positive, because we all know work is positive when force and displacement are in the same direction, and it is negative when they are in the opposite direction. As simple as that. Okay, let's move ahead to the next one. A charge q is located at the center of a circle. Okay, the work done in moving a test charge q from point A to B at opposite ends of the diameter. Guys, this question also I did yesterday. If you remember, it was there in my sure shot. There were 4 diagrams given, and I told you where maximum work is done, and I told you when you go from one point to the other point on the same circle, the potential is basically same. So potential difference is 0. So work done is also 0. Work done is also 0. I had told you this in the class. This question was done yesterday. You were there already. Okay, next. A long solenoid carrying current produces a magnetic field along its axis. If the number of turns is halved and the current is doubled, the new magnetic field will be direct application of formula mu naught Ni. Mu naught Ni. So if N is made half, and current is made 2 times, 2 into half, that's going to be 1 time. That's basically the same thing, so it's not going to be changed. Very good. Let's get moving to the next one. Okay, I think assertion reason questions. Well, so let's have a look at the assertion statement. There is a bar magnet which experiences torque when placed in a magnetic field. Okay, so we have a bar magnet which experiences torque when placed in a magnetic field, and a bar magnet exerts a torque on itself due to its own magnetic field. This is something wrong. Okay, bar magnet when placed in somebody else's magnetic field, this is external field, then it experiences torque which is given by M cross B. This is always external. Own field cannot apply a force on itself. Okay, so own field can't apply force on itself. It's like asking, there is a charge which creates electric field around it. Will this field apply a force on this charge? No, this field is created by this charge. This field can only affect other charges, not the charge itself. Same way, this magnet's field will affect other magnets, but not the same magnet itself. So that's why option C is correct. Where reason is false, assertion is correct. Moving ahead to the next one, coming up on your screen. In a series LCR circuit which is connected to AC source, resonance can take place. Yes, why not? At resonance, XL is equal to XC. So when this condition is met, so basically this is the condition. So when this condition is met, then resonance will occur. We all know that XL and XC will cancel each other, and the total impedance will just become the resistance. Perfect. This is also true, and it's explaining it. Very good. So why not B? Because it is explaining it. If it is explaining it, it's the correct explanation of the statement. Okay, Kamlesh. All right. So we have a charged particle which moves with certain velocity in a magnetic field. They both are perpendicular. The force on the particle does not do work. That is very true, because in F is equal to QVB, the force is always perpendicular to velocity. Work done is F dot displacement. Velocity and displacement same direction, so work done is 0. The magnetic force is perpendicular to the velocity. Perfect. That means the work done will be 0. That's why no work. Hence it is correct. Excelente. Moving ahead to the next one. Okay. So focus is saying it is not explaining why it is resonating. See, that's the whole ambiguity. At certain times I have seen this assertion reason questions, depends on what kind of reasoning you are expecting. See, I can give you a certain reason for a particular phenomena or a question. Somebody might say, okay sir, I understood. Somebody else might say, no sir, I am not convinced, I need more reasoning. So that's why these kind of questions were deleted from JEE Mains Advanced. Earlier it used to be there, and there were a lot of ambiguities, there were a lot of clashes between all students and so many institutes. Okay, no, I feel this reasoning is fine. Some students used to say, no, I need more explanation for the same assertion. So that creates a lot of ambiguity out there, especially when, both the statements are correct, and when, we have a partial reason, but maybe sometimes one line or one statement is missing, and then you are not so convinced. So it becomes very ambiguous. I will admit to it, okay, because there will never be enough statements to convince you then. Okay, you will never be convinced. The reasoning will never be enough. So it's always a problem. Okay, so induced EMF in two coils made of wires of same length and the same thickness, one of copper, another of aluminum, is same. Okay, the induced EMF is same. The current in the copper is more than that of the aluminum. Acha, the resistance of aluminum is more than that of copper. Okay, so induced EMF. So we have coils. If we have EMF, that current will be EMF by resistance. So the current in copper is more. So if the current in copper is more than current in aluminum, resistance of copper obviously is less than resistance of aluminum. That's the only logical explanation. That means it is correct, this is correct, and everything is fine. Let's get moving to the next one. Okay, a transformer is used to decrease or increase AC voltage. A transformer works on the basis of mutual induction. Okay, so yes, a transformer is used to increase or decrease, basically step up or step down. Yep, so you can use it as step up and step down transformer. That is perfectly fine. Transformer works on the principle of mutual induction. Yes, there are primary coil, there is secondary coil. Field lines go between the primary and the secondary coil. But that is not explaining why you can increase and why you can decrease. Both are true, but it is not giving the explanation for that. Why you can increase and why you can decrease. Okay, so let's get moving to the next one. No, this is not A, this is B, guys. This is going to be B. Yeah. So it's not correct. Okay, all right. Chalo, let's get moving to the next one. Two charged spheres A and B having the radii in the ratio 1:2 are connected together with a conducting wire. The ratio of the surface charge density will be how much? Okay, so sigma, okay, what you can do, sigma is inversely proportional. Okay, they are connected. Two charged spheres A and B having radii 1 and 2 are connected together is the conducting wire, the ratio of the surface charge density. So what can you do for sigma? Sigma is nothing but charge by area, correct? And the next thing is, because these two spheres are connected to each other, the potential of this guy and potential of this guy will be equal. So that means what will happen? Think K Q1 by R1 will be K Q2 by R2. So Q1 by Q2 will be R1 by R2. Now radii are in the ratio of 1:2. So Q1 by Q2 also is in the ratio of 1:2. But remember, even the area will be different. So strictly speaking, sigma 1 by sigma 2 is Q1 by Q2, and here you will have A1 and A2. So this is nothing but Q by Q2. Area is 4 pi r square. So this will be R1 square and this will be R2 square. So Q1 by Q2, I just got it as 1 by 2. R2 by R1 is nothing but 2 by 1 whole square. So this should be 2 by 1. Just check this out. I'm not sure why it has been marked as D. Just check this out. Where are you getting this answer as B? Just check this out. Just check this out. Two charged spheres A and B having radii this are connected together with a conducting wire. The ratio of their surface charge density, it should be 2:1, guys. It should be no VS key, no, it should be B. B is the answer. Okay, so again, I think there is a printing mistake out here. Okay, I'm just going to change it. Yep, VSK, it will be 2:1, bacha, not 4:1. Okay, I think there was a small, it's not field. The question is not about field. The question is about charge density. Be careful. Even the radius is different, area will be different. Oops, sorry, not C, B. B should be the answer. Okay, I'll just put it over here. Why am I taking Q1 by Q2 as 1 by 2? Because potentials are equal, bacha. I just told you, na? If the two spheres are connected to each other, the potentials are equal. If potentials are equal, K Q1 by R1 will be K Q2 by R2, right? Because the potentials are equal. That's the potential of a sphere. So that's why Q1 by Q2 is R1 by R2, which is 1 by 2. Why R1 by R2 is given to be 1:2, the radii. That's why. Got it? As simple as that. All right. Moving ahead to the next one. No, Manav, it is surface charge density. Why will you take volume? And remember, if they are connected to each other and the charges flow, it's a conductor. And in a conductor, the charges, where are the charges? They are not in the volume, they are only on the surface, bacha. They are not in the volume. Even if it is a solid sphere, the charges only come on the surface. They are never in the inside. Okay. Yep. That's the reason for that. And sigma was charge by area. And charge by area means charge by 4 pi r square. So that's why sigma 1 by sigma 2 was q1 by q2 into r2 by r1 square. This was 1 by 2. This was 2 by 1. So what will it be? 2 by 1. Got it? Got it? Understood? Area is proportional to r square. Correct. Understood, VSK? Got it, bacha? Shall we go ahead to the next one? Yeah, so in 49 question, it is only given voltage, sir. The transformer also changes the current. The current change happens because of energy conservation. It happens because of some other reason. It happens because of energy conservation, not because of something else. Okay, chalo. Let's get moving to the next one now. Okay, a current carrying square loop is suspended in a uniform field acting in the plane of the loop. Okay, so if the force on one of the arm of the loop is F, the net force on the remaining 3 arms of the loop will be. Guys, whenever you have any kind of loop, okay, and it is suspended in some magnetic field, then we all know the net force is always 0. There is always like a couple force, net force is always 0. So if force on one of the wire is asked, remaining wires force, if it is added, the net force has to be 0, and if this is F, obviously this should be minus F. Just think about it. Makes sense, right? No. Magnitude wise it will be F, but direction wise it should be opposite. Be careful. Okay. Q1 by Q2, how will it be 1, bacha? VSK. Q1 by Q2 will be 1:2, you know, in the previous one, because potentials are equal. Okay, VSK, let me tell you, when you connect two things, charges don't get divided equally. Charges get divided depending on the potentials. Potentials are equal. That's where you made the mistake. Chalo, let's get moving. Case study. Battery is a combination of 2 or more cells. Okay, these are batteries in parallel. Internal resistance is also given. The questions are as follows. Equivalent EMF. This is direct formula, guys. Just check this out. These two batteries were opposite. These two batteries are opposite. One is facing this way, other is facing this way. So if you did not pay attention to that, then you would have mostly marked this. How many of you made that mistake? The correct answer is this one. This minus sign is there. This minus sign is there. Okay, that's how it is. Okay, very good, very good, very good. Acha, somebody is asking, sir, in the same plane, how is the force there, bacha? See, even if it is in the same plane, B is here, area vector is here, and there will be IL cross B forces. L is perpendicular to B. That's why there will be force. L cross B forces will be there over here, perpendicular to that. So yes, so the remaining part will experience force in exactly opposite direction. That's why it is creating a torque. I hope that makes sense. Moving ahead to the next question. For the terminal B to be negative, yes, for terminal B to be negative, then what condition should be met? What is terminal B? Okay, so for the terminal B to be negative, that means the net EMF should be negative. So net EMF should be negative means E1 R2 minus E2 R1 should be negative. That's it. So that's all. That's all. E1 R2 minus E2 R2 should be negative. That's it. So make this numerator as less than 0. That's it. Make this numerator less than 0. Okay. Okay. Next question. A current in the internal circuit. The current in the internal circuit is what? Acha. Now let's see how to do this particular question. See, I think what they meant over here was if the total voltage drop, is 0, only then you will get the answer probably. Yep. Yeah, there should be something else given, because only then you can find the current in the internal circuit. Okay. So if only this much is there and nothing else is there, assuming it is not connected to anything, so there is no connection anywhere. Okay, there is no connection anywhere, only this internal circuit is there, then there will be no I1, I2, whatever current is generated here, there is nowhere to go, it will just flow over here. Okay, so that's probably the only way I can assume it to be. And if that's the case, the total EMF, just check this out, the total EMF, will it help each other or subtract each other? That current will be the total EMF by the total resistance. Just check this out. What's the total EMF? Will it help or will it cancel? I think it will help each other. So that time it will be E1 plus E2. E1 plus E2, and R1 and R2 are two resistances. R1 plus R2. Just check this out. Yep, just check this out. It should be option C. Now they are in parallel. Yes, they are in parallel. Correct. Okay, so I think over here, yeah, option C. Oh my god. This should have been option A, guys. This should have been option A. I'm just going to change it. This should have been option C. Sorry, A. I'm just going to change it. Don't worry. Looks like. Okay. Just hold on over here. A lot of controversy is being created over here. Okay. Yes. Current can be solved by EMF equivalent by R equivalent. Yes, that's all you need to do. Yeah, so they did not mention any conditions. So see, the moment they mention this word, current in the internal circuit, that means external circuit is not there. So only this much is there. So if only that much is there, the current will only flow in this much part. It will just keep circulating between these two batteries. So when it is circulating in these two batteries, these legs don't matter. So that current will be the total EMF by total resistance. So total EMF will be E1 plus E2, total resistance will be R1 plus R2. Okay, so just check this out. If nothing else is mentioned, then it will be E1 plus E2 by R1 plus R2. The equivalent internal resistance, that's a resistance of parallel. So R1 is parallel to R2, so it should be this. That's it. Okay, that's all. That's all. Okay, I hope that is clear. Oh my god, they are not in parallel, bacha. They are, yes, see, okay, going back to this diagram. Do you think they are in parallel? Just check this out. Where did it go? Guys, tell me one thing. When I remove this, and when I remove this, is E1 and E2 in series or parallel? Just forget that. Just forget the outside part. Just concentrate on this circuit. Only concentrate on this circuit. Now tell me, are they in parallel or in series? They are in series, right? They are one after the other. This diagram is as good as saying this is one battery, this is another resistance and another battery. That's it. This diagram and this diagram is the same. Now you can clearly see both are assisting each other. Both are assisting each other. Got it? My warriors, they are not in parallel. Only when are they in parallel? When the current comes from outside, gets distributed and again combines over here, and again then comes. When it gets distributed and when it is connected to some external circuit over here, then it is in parallel. Otherwise, it is not in parallel. Understood this? Yep. Now, what is my analysis? What is my analysis? The way it is, let me tell you. Okay, perfecto. My analysis says that the this current set, SSJ1, okay, this SSJ1, this looks more difficult than as compared to SSJ2. So if you had SSJ2, this was very, very easy. If you had SSJ1, then it was average. I would say some questions were definitely debatable. They were controversial, and some questions, this was only in assertion reason, that's what we saw, and some questions were not mains level also, but they created some calculations. So they had some calculations, or basically some kind of logic was required. So if you are SSJ1, you are a little bit unlucky. If you are SSJ2, you are very lucky. Yeah, that's what I would say. But on a much broader perspective, this paper was definitely less than the JEE mains, level. I would say this was very close to the NEET level. Yes, this was very close to the NEET level. So if you are a NEET student and watching this, so I feel this was very close to the NEET level. That's it. Probably NEET level will be slightly more difficult than this. That's what I would say. Yep, if the questions are ambiguous, it should be definitely challenged, and you should definitely get bonus for that. Yep, you should definitely challenge for it. Now, in the second paper, I would feel that even if you have got 30 marks, that is good. But in the second paper, if you have got 33, that's okay. But in the first, the first paper was done later on. Okay, so in SSJ1, if you have got 30 to 33 marks, it's okay. Here, you should have got full marks. There is no doubt about it. You should have got full marks. Okay, hardly one question, two questions you could have lost marks, maybe 34, 33 around, but you should have got full marks out here. Now, what is the plan ahead? Because chemistry will be done in the next 3 days. In the next 3 days, after you complete your chemistry paper, I am pretty sure you want to start studying for KVPY or JEE. How many of you want to start studying for KVPY? How many of you want to start studying for JEE? How many of you want to start studying for NEET? How many of you want to just prepare for boards? Please tell me in the chat box. Please tell me in the chat box. Okay, what is your immediate goal? If it is multiple, if it is JEE plus KVPY, then you can mention that. If it is JEE plus KVPY, you can mention that. So Madhu saying no plans. Oh my god, that is not good. Okay, I can see a lot of JEE, some of you NEET, and many of you also saying KVPY. JEE plus KVPY, JEE plus board. Okay, so okay, great. So here is what I'm going to do. I'll be telling you about what the next plan should be on Sunday, how we should prepare ourselves for the next competitive exam, and in the days and weeks to come, we'll have KVPY classes also on YouTube, definitely. Do you want me to cover term 2 syllabus on YouTube? Because I've already just started with the term 2 syllabus of 12th standard. You want me to do that? Do let me know. Yep. So Chem revision will happen tomorrow or tomorrow onwards, or probably tonight onwards. Definitely. That's one thing. Also remember, if you want to revise the entire syllabus and you want help in test series or assignments, then go ahead. There is a link in the description box where you can join the crash course. This crash course will have 90 sessions for 11th and 12th classes, 10 full syllabus, 10 part syllabus, and you can also compare your marks with previous year toppers. You will get plenty of assignments to solve. That's one good thing about this. And you will get doubt solving also within the a particular class and even after the class. So if you are wondering where to start your preparation and how to start your preparation for the final leg of JEE, all you need to do is go below over here. You will see right over here the CBSE term. Okay, just click on any of these links. Let's say for example grade 12. Just click on this as change and just say JEE 2022 crash course. That's it. You will see that the crash course link will pop up. When is this course starting? This is starting this Monday. This is starting this Monday. Now you might be wondering, sir, I have chemistry exam. Don't worry, you will also get replays of whatever classes you missed. I feel you should start early. The better it is if you start early, then it is definitely a plus point, or else you will waste some time over there. If you are wondering what's the price, it's 9,000, 10,000, but this classic version, which also gives you doubt solving, is available at 9,000 rupees just because you have gone through the link and clicked on my coupon code SHHPRO. So that's the benefit of it. You get 1,000 rupees off, 10% off. Not just that, any problem happens, you can directly get in touch with me. That's what happens. Okay. So all the best teachers, the timetable, everything has been mentioned over here. Once you join it, oh, by the way, I forgot to tell you, this crash course is also going to be in English. This is in English medium. Very, very important for most of you. Now, when are the expected dates of JEE? All of this I will tell you very soon. I have some internal news. I'm just doing my research. Let me tell you all the details, but it's going to be very soon. You cannot take it as a surprise. Oh my God, suddenly JEE has come up. You cannot do that. Okay, so the news will come. You cannot react to that. You have to prepare before the news comes. So that's why start your journey, not just on YouTube, but also via the crash course. I have already showed you the link, and I'm telling you, this is 9,000 rupees. This is an offer which is there now. It might go up, it might come down, I don't know, but chances are that you might lose out on time. That is more important than the money. So go ahead, check it out, and thank you for tuning in. First of all, Pathfinder for term 2, yes Yuki, I'll do that definitely. Manish, JEE exam should happen somewhere in February or March. It's going to be very soon, definitely. Okay, so take care guys, have a great time, and thank you for liking the video, thank you for sharing the video, thank you for subscribing to the channel. Have a great time. I'll be seeing you very soon. All the best for chemistry exam. Don't worry about what happened now. We will work on term 2 now. Okay, so you have realized at least that much, that attending classes is very important. Whatever I do is very, very important because it comes in the examination. All right, so don't worry about it. Take care, have a great time, and all the best guys for the chemistry exam. Thank you very much for tuning in. This was Shreyas here. Hasta la vista.